the major issues of data mining. The major issues, one, we were talking that it will be different kinds of knowledge in the databases. So different kinds of knowledge, we will be assuming it as clustering followed by classification and association. And these, they are going to be applied over the data warehouse. This is the first primitive what we are going to talk. Second was the background of the knowledge. So when asked to choose a mini project, you say, I am looking for a project which I can classify COVID cases. I am looking for a database which can classify a number plates, or which I can classify a diseased plant leaves, classify different roses. So in this way, what type of issue we are going to take, those we are going to call here as an background knowledge. Next thing was, we have SQL language to do the Oracle queries with the database management system. But to operate over data warehouse, we need data mining query language. So this data mining query language is going to make a temporary queries. So coming to this data mining queries, it is going to be treated up with a data warehouse, and finally we are going to present the results in form of visualization. So visualization, it is impacting more on the graphs. Now the input to a data warehouse, we are going to call it as a pre-processing. So to do the pre-processing, we were mentioning that there will be missing data, there will be noisy data, etc. So in such a case, data is incomplete. So we are going to work with data pre-processing techniques so that we will make the data as pure. Finally, we are going to communicate the result. Finally, we are going to communicate the result. We call that one as a pattern evaluation. So when doing pattern evaluation, we are going to have historic data, or we are going to call it as past data. From the past data, we are going to apply the techniques, and thereby we are going to forecast the future trends. So using this technique, we are going to find the pattern, then we are going to predict, or we are going to make a forecasting over the data. So that is how we will give a quick business insight. Now while doing all these three things, we will go with a performance and we will look with the scalability. One, we are going to look at the performance. Two, we are going to look the primitives at scalability. If the primitive was towards the scalability. Now we will look the space complexity, and we will look at the time complexity of algorithm. So this, it is going to depend on the algorithm memory and CPU. So these two are going to be a parallel factors in order to indicate how efficient the algorithm is going over the database. So for that, we are going to interpret. Now coming to the CPU speed, so it depends on a parallel two or more contents distributed. People in a network communicate, and thereby they share the tasks among, thereby an incremental mining. So working on first set, then moving to the next set, then moving to the next set. So you are going to make a incremental approach. You are going to look into an incremental approach where this approach will lead up to the performance and scalability factors. The next thing was, what are going to be the different data types it is looking. So mostly it works with a numeric data, or it is going to work with a character data. Mostly it goes with numeric data or character data. When we are going to call it as a numeric data, we can work with an integer or float values. So again, it can be short int, it can be long int, and a general integer. Float, yeah, it can be extended to a double, etc. Similarly, another complex data types, it will be the date, or it will be the multimedia database. So what is multimedia database means? We are able to make or do predictions over images, do predictions over video, audio. So all these, they are going to be part of the multimedia data. The next comes heterogeneous data. If we are going to take multiple sources, if we are going to work with multiple sources, so one source will be a database, another source will be a flat file, another will be a cloud. So now you are taking data together, then you are going to integrate it, and thereby you are going to put it in the data warehouse. So multiple sources, you are going to call this element as a heterogeneous database, because we take it from a relational database management system, we take the content from a flat file, we take the content from a cloud, integrate the things and put it to a data warehouse, and thereby we are going to interpret the things. Next thing was, the queries are going to be intelligence. So intelligence we are going to call here as a predicting. So this is business intelligence. So what the end objective was to gain a quick insight or give a forecast. So tomorrow's business, how it is going to affect. So that will be the most way of intelligent answering. So and people, they can do a good or a wise decision making. So these are some of the impacts where data mining is going to make a key role. Next comes a word called as a domain specific. It can be health sector, it can be an education sector, a finance sector, banking sector, or a e-commerce sector. So to what type of domain we are going to apply, that domain knowledge is going to be needed out while making a strategy of the data mining tools. So again, if we are talking about the data mining tools, Yes, you need to look into clustering, classification, association, etc. All of these things are going to put together. And finally, we are going to make a read privilege, a write privilege, open privilege, close privilege. So in this way, we are going to make different set of operations, giving some passwords, giving some access matrix, and writes with some grant, revoke, rollback, and commit. So all these options, they are going to make the privacy, they are going to provide data security for the data which it is going to be in the data warehouse. So this is all about the words what we were talking about the major issues. So we started up with the major issues towards the knowledge, which we look the knowledge from the different dimensions, that is towards the clustering, towards the classification, towards the association. Then in a general database, we will use our relational database management system, Oracle or SQL. But if we are going to do it on a data warehouse, we mostly look at the data mining query language. And the inputs to the data warehouse, we are going to call it as pre-processing, where we will eliminate noise, where we will eliminate incomplete data, make the data as pure. And finally, we will do a pattern, and that pattern we are going to communicate to the end user via the graphs, etc. So in order to identify the efficiency of an algorithm or a scalability of an algorithm, the most factor was the CPU time and the memory time. So memory, it is with the space complexity. The speed of an execution of an algorithm, it is going to deal with the time complexity. The main intention was that we will have a historic data. From the historic data, we need to predict or we need to forecast the future and give a quick insights. Another issue was to get the data from a heterogeneous content. So we can get data from a relational database management system or from a data set from Kaggle or other public GitHub or any public repositories, which it is going to be stored in .csv format, which it is going to be stored in comma separated value format, and clouds, etc. There you are going to bring it together. So bring it together, we are going to call it as heterogeneity, because we are going to take it from different sources and putting to a data warehouse. So this is what a heterogeneity is talking about. And complex data types, yeah, you can store image, video, audio with a general data types like numeric storing integer or a float, character storing the strings or character operations. So domain specific issues, they are related to a health or a finance or a banking, etc. And security mechanisms, it deals with passwords, access matrix, etc. And most importantly, the privacy, the integrity, it is going to be maintained with some data mining query operations like grant. The next word, what we need to take up here was the data mining primitive languages and system architecture. The other thing was data mining primitive languages and system architecture. Again, we will have some repeated items which are going to have focus again. So these repeated items I just finding the patterns we have already discussed. That too we need to take it from raw data. So that's the reason why it is totally unorganized. We need to bring it into an organized way so that the uninteresting pattern should be more precise and more understandable to the end user. So for that we need to provide some set of primitives, and these set of primitives, they are going to be integrated with a data mining query language. So as mentioned, when we are going to say it is an SQL content, it is going to be purely based to a relational database management system. But when we are going to make a query operations, etc., over a data warehouse, at that case, we are going to use this data mining querying language. So what are the some of the specialities of the data mining query language means? Yeah, it is going to have a graphical user interface. So user can have an extreme way of using, so a flexible interaction, and it is totally practiced with the industry standard. So industry oriented applications can uh, be customized while using this data mining query language. So what will be the things in the data mining query language tasks? One, we are going to call it as task relevant. The query what we are going to suppose to answer. So that is what we call here as a task relevant. Then the type of knowledge to be mined. It can be with clustering, it can be with classification, or it can be with some association. Next, we need to have the background knowledge. So background knowledge, domain specific. So today maybe you are in the general academics, but tomorrow you will work to some corporate company, and suppose that corporate company is doing a business with a bank. So obviously you should have knowledge on the banking sector. So how a banking sector does, what is a saving, what is a debiting operation, what is a crediting operation, how people check the balance, so how people will go with term deposits or fixed deposits. So in this way, banking transactions, you need to have that knowledge. So as we do it as a computer science, it doesn't mean that we do C, Java or Python. C, Java and Python are the languages, and that language's content, we need to give it to a specific domain. So domain we call here as a background knowledge. Fine. The next thing was we need to get the data in an organized way, what we call it as pattern interestingness. So let us say I can say it is 1 first year percentage, second year percentage. So I can say it is 8.5 and it is 8. So now what will be my percentage for the third year? So I am going to have the past data here. Now I am going to make a future prediction. So if the same trend is going to continue, maybe it will be between 8.25 as a CGPA. In this way, some type of pattern we are going to identify. Then how you are going to make a visualization means I will put some chart here. So first it is 8.5, then it came to 8. maybe it will increase in between. So in this way, we are going to put some way of visualizing and demonstrate to the end user whatever pattern we have identified. So that need to be demonstrated. Fine. Now, where is this DMQL operated? So where is this DMQL operated means DMQL will be operated with form of a database, a large database, and that large database applicable to some specific content. We say a banking sector or a finance sector, and it is going to be a vast repository. So we call here as a data warehouse. Next thing, when we are going to call it as a data warehouse or a large table, now the content it is going to be organized in form of tables. So tables, we will say it is row and column. It is a two-dimensional way. And when we talk about data warehouse, it is going to be represented in multi-dimensional way. This is the first difference why people are migrated towards a data warehouse. So in databases, we are going to have the contents in two-dimensional way, but in data warehouse, we are going to represent the things in a cubical format, in a three-dimensional format. So here we have x-axis, y-axis, but when we talk about a data warehouse, we will have x, y, and z. So three way of putting the things in three dimensions using operations called as slicing, dicing, pivoting. So using these operations, we will render the knowledge from the data warehouse. So what is dicing, what is slicing, what is pivoting? We will discuss it in unit 2. And the next thing was we have some conditional for data selection. I will recollect the example what we have taken earlier, data selection, removing of irrelevant databases. Assume there is a student database with student number, student name, blood group, 10th marks, inter marks, BTech marks, and MCET rank. Assume there is a database with student mobile. So student mobile, student name, blood group. So it is A positive, O positive, O, B. So different blood groups are there. Then 10th class marks, inter marks, BTech marks, and MCET marks. Now let us say I am looking for students whose blood group is A positive. So this is my task. So I am looking for students. I want the student contact of having A positive. So now this was the database which I am going to have. So I am putting the words here, data selection, and I am putting the words called as relevant attributes. So when we say it is a data selection, unrelevant attributes to the query should be removed. So for my query, what is the question is, select the students who are going to have the blood group. So obviously mobile number is enough, student name is enough, and blood group is enough. These three fields are enough for me to answer my question. My question is, pick the students who are having blood group of A positive. Rest of the students, even though they have O positive, B, C, etc., I am not looking at that because my question is very specific, my task is very specific. So that is what we are going to call here as a task relevant data. Now, we need to eliminate the irrelevant attributes because of space complexity, because of time complexity. So there is no reason putting students MSET rank, putting 10th class marks and BTech marks or intermediate marks into this query. Of course, the master database will have all the entries, but my question was what is the blood group of the students and give the contacts for A positive. So I need to be very specific in bringing those things. So that is where we need to make a grouping, etc. The next thing what we have to check was what kind of knowledge we are going to interrupt from the databases. So if such is a case is going to happen, we can look with characterization. That is, I mentioned a pen which has a length, it has a height, it has a width, it has a color. So discrimination, taking two pens, one blue color, another green color. So you discriminate the two parts. So this is with green color, this is with orange color. So you discriminated one color with another color, you compared with source class with the target class. So that is where we bring the word here as a discrimination, followed by association. So association, you are going to make some correlation between attributes. We are going to make a correlation between the attributes. So attribute 1 and attribute 2, you are able to correlate, and then you are going to identify what will be the third content. The next thing was we use the word called as supervised learning, where at this time we know the labels. We know the labels in advance. So the training or the testing data set, what we will do. So labels are already known. So whether to put into that label or whether not to put into the label. So we will classify the things. So there we will use a decision tree, we will use a random forest, uh, we will use Naive or Bayesian algorithms to do the classification. The other word was clustering algorithms. So clustering algorithms we mentioned earlier, it is going to be called as supervised, unsupervised learning. And in this unsupervised learning, labels are not known. So whatever labels we are going to check, those labels are not known to us. So specifically we should create a label here. So how we are going to do that means we are going to make a similarity. So how we are doing this similarity means, yeah, we will look with intra-cluster and we will look with inter-cluster similarities. So given tomatoes and potatoes, we will divide it into two groups, tomato as a group and potato as a group. But when we check whether the two potatoes are same, definitely not. But the color, the race, etc. will match us. So you discriminated tomatoes with potato. But if you take two tomatoes and check, definitely they will not be same color, same size, same orientation, etc. So there we will call the similarity as an intra. Distinct between tomatoes and potatoes into two separate baskets, we call it as an intra cluster. So this is how we will put the things. So the next way of putting the data mining queries was to divide the things into knowledge hierarchies. To divide the things into knowledge hierarchies. Now let us talk about the academic structure. So you know your professors, you know your associate professors, So these three categories you are aware of it. So in the academic line, in the colleges line, so what is the concept hierarchy means? Yeah, we say faculty are in assistant tab, faculty are in associate tab, faculty are in professor tab. So there is hierarchy 1, hierarchy 2 and hierarchy 3. In this way, we are going to mention the way of representing the knowledge into different levels. So now let us take another example. We are going to call this one as a scheme hierarchy. So in this scheme hierarchy, let us say I just want to make a postcard. So it is a 10 rupees stamp here. Then they will write 2. So in this way, we are going to have some envelope. So when there is an envelope, now what they will write is to the person name, then they will write to which street he belong, then the door number, street, etc., to which city he is going to belong, then to which state he is going to belong, and to which country he is going to belong. So in this way, they are going to put the things into different levels. So level 1, his name, level 2, his street, level 3, his province, his country. So in this way, we are going to put in different granularity. So such type of managing the content in different granularity, we are going to call that one as a scheme hierarchies. The next word was set grouping hierarchy. The next type of background knowledge, what we need to understand will be the set grouping hierarchy. Let us say I have 180 students. I have 180 students and I was assigned to do set grouping. So in this set grouping, if I have to do, then what I will do is for CSCA students, okay, roll number 501 to 565. So I am putting this into one group. Then for CSCB, I will put a label from 5C6 to 5C9. I will put it in the C section group, B section group. Then I will take another group called as C section. Then I will give from 4D0 to some 4I6 or etc. into another group. So now what was happening here was I look with set grouping. So in this set grouping, I am assigning the students to 2 to 3 different labels, 2 to 2 different classes, and each class name is going to be unique, and I am distinguishing between serial numbers. This is the first way of dividing the things into sets. So here is an example. Let us say that students whose age or people whose age was between 20 to 39 years, we are going to call those people as young. And people whose age is going to be between 40 to 59, we are going to call them as middle-aged. The same thing I am putting to our academic understanding, that is the set grouping example. Students who are having a register number between 501 to 565, I am putting these into one section. So, and I am giving a label here. So, here the label was young and the age was 20 to 39. Now, here the label was CSCA and the group was 501 to 565. So, this is how a background knowledge is going to be demonstrated into different levels. So, we call that interpretation as a concept hierarchy. The next thing was operation derived hierarchy. The next thing was operation derived hierarchy. So, in this operation derived hierarchy, we are going to mention, so CSC DEPT at the rate of svecw.edu.in. So, assume this was my email. This was my email, CSC department at the rate of svcw.edu.in. So, in it is going to stand for the country here. In it is going to stand for the country. So, this is one level. Next one, the university, what we are going to put. So svcw.edu, so it belongs to a domain called as .edu. So there are some commercial websites, we call it as .com, military websites .mil, and national informatics centers like NIC. So in this way, we have different types of domain. So we call here as a domain specific here. And now edu, it is going to be education domain followed by a university or a college to this appropriate example and followed by the login name or the department. So in this way, we are going to put a operationally derived hierarchy which we are going to pose. Similarly, I can write like this. We can write like this: 19B0, 1A0, 501. Now, if this is going to be the register number, now what was the operational derived hierarchy? I can say 01, it is going to represent number, 05, it is going to represent the department, B0, it is going to represent the college name, 19, it is going to represent the academic year of admission, what you have mentioned. So in this way, we are going to put up the operation derived hierarchy where we are going to prompt the knowledge. So in one specific word itself, the entire knowledge we are able to communicate in one specific way of representing the data, we are able to push the knowledge here. So 19B01A0501. So your register number is going to have such much content when it is subdivided into different levels. So this is what we call here as a operational derived knowledge. The next thing was we need to talk about rule-based hierarchy. So in this rule-based hierarchy, we will say that we are going to have an example low profit margin, which it is going to be less than or equal to price with x comma p1. So this is condition 1, this is condition 2. So whether condition 1 in that specific range is meeting to a condition 2 in that specific range, we are able to derive it. So there we are going to call that word as a rule-based hierarchical system. Now, how we are going to predict the content, nor how we are going to make the pattern interesting was, we call that word here as the pattern interestingness. We are going to call this one as pattern interestingness. So pattern interestingness, it deals with the two words. One, we are going to call it as simplicity. Two, we are going to call it as certainty. So when we talk about a certainty, we are going to call it as a confidence. So let us say the word people who are going to purchase bread and people who are going to purchase milk. So this was what we are going to say, will definitely purchase jam. So people who are going to purchase bread and people who are going to purchase milk will also purchase jam. So now I am going to fix up this. On what support and what confidence we are going to take up means we are going to use a probability factor between two events, and these two events we are going to make an AND operation between these two events, and the number of occurrences we are going to divide. So this is how we are going to make a statistical inference, a statistical rule we are going to maintain, and then we are going to strengthen the confidence. So association is that people buying bread people buying milk will go with a jam. So this is attribute 1, and another one was attribute 2. So we are including or we are joining two attributes to derive a new one. So we say here as an association. So this association can be extended towards a decision trees. So whether the country will win the match today or not. So in this way we will predict. So when we are going to predict, we will check lot of factors. So those lot of factors, they are going to be posed in form of branches, nodes, leaf nodes, middle node and end node. So this end node, they are going to give the decision whether it can be true or whether it can be false. So this is how we break this things of patterns as interestingness. The next measurement towards identified pattern was is good or not, we are going to call it as usefulness. So whether it is really potentially useful with the content or not is going to be derived. So that is what we call here as a potential useful. And next one, whether it is fresh, whether it is new, whether it is correct or whether it is accurate. So all this we are going to treat, we call it as a novelty, a fresh idea. So we ask you to, when we tell that you have a project work, a mini project work or a main project work, you come up with a title and we say this title, this abstract is existing because we have seen it somewhere else earlier and we don't want the same topic and to look for a better project. So some new idea has to be included it. So where we are going to call that one as a novelty. So not previously known. It should be new to us. It should be fresh to us. So then only the pattern is going to be fair or pattern is going to be very interesting. Now, how we are going to represent the patterns? So that is what we call here as a data visualization. So to make this pattern interestingness, we are looking to represent the knowledge. It can be with rules, it can be with tables, it can be with cross tabs or a pie chart or a bar chart, etc. All they are going to represent it in the different forms. Next thing, we talked about the concept hierarchies. So concept hierarchies I was mentioning, it can be with professor, it can be with associate professor, or it can be with assistant professor. You represent the things into different levels of knowledge in a very abstract way. So that is what we call here as a concept hierarchy, and the discovered patterns were represented in form of rules, in form of tables, in form of pie charts or graphs or etc. All this we are going to be represented. So that is what we call it as discovering of knowledge. Similarly, when we are going to work with three-dimensional data, that too we call it as cube, or we are going to call it as multi-dimensional data. So this multi-dimensional data, we are going to represent it in data warehouse. So the basic operations what we are going to do on a multi-dimensional data, they will be some drill up, nor drill down, or pivoting, nor dicing, nor slicing. So all this we are going to make the different operations for the data warehouse, which we will be discussing in the next class. So I can say there was a cake here and I take a part from it, you call it as a slice. So some partial input from the main content you are going to bring up, you call that one as a slice, and putting the things January, February, March, April, May. So you have the 12 months and all the 12 months total you are going to put, this is what we call it as drill up. But if I am calling it as drill down, if we are going to call it as drill down, then it says every month total we are going to display it. We call that item as a drill down. So some January sales, it is 100. February sales, it is 100. In this way, we are going to put point to point individually one to one. We are going to call that item as a drill down. Now I will put all the consolidated, assume it is 1200 at a stretch. If we are going to put that things at this model, then we are going to call that item as a drill up. So in this way, we are going to represent the patterns. So what we have learned for this content as of now was the topic what we have chosen. The topic what we have chosen here was the data mining primitives. So at this data mining primitives, the main intention was to find out the pattern and to describe the pattern. So to find out the pattern and describe the pattern, we need some tool, we need some language. So that language, we are going to call it as a data mining query language. So we need to communicate it to a data warehouse. For that, we need to have the graphical user interface. So now where is this data mining query language done means? We will do it for a specific task. We will do it with some type of knowledge or some specific domain. Domain can be health, finance, etc. Thereby we need to find the pattern which it is going to be interesting, and that pattern need to be visualized. So that is what we call it as visualization of the pattern. Now coming to the first word called as task relevant. So task relevant, we will take this from a larger databases or a warehouse, and then we will select the attributes which are needed to it. We call it as data selection. So that is called as relevant attributes. Irrelevant attributes, the unnecessary attributes are going to be removed. So things which are needed, things which are not needed, you group the two items, grouping of the fields, etc. Next thing what we will do is we will apply the knowledge. So knowledge, we have lot of techniques like clustering, classification, association. All those knowledge algorithms are going to be implemented, and thereby we will implement these things into granularity, into multiple levels here. So one type of level concept, we call it as a schema hierarchy, where people will write their postcard name with the name followed by their street, by their home address. So when we talk about the home address, so they will write the home address into different levels like name, street, city, state, etc. In this way, they are going to write the things. So we call it as a scheme hierarchy, and thereby we are going to call it as a set hierarchy. So CSEA, it will be between 501 to 565. CSCB between 599 to 569. In this way, we divide the things into different groups. So we call it as set grouping, and followed by the operationally derived hierarchy. In this way, we have an email with login name, department name, university name, college name. So CSE department at the rate of svcw.edu.in. So in stands for a country, edu stands for a domain, svcw stands for a college, and followed by the login name called as CSE department. So we do these things as part of a operational content, and thereby we need to look with the measurements of a pattern. So measurements of a pattern, they will follow with measurement of patterns will go with the more interesting words like simplicity. So simplicity, it deals with association. We take attribute 1, we take attribute 2, and we make a correlation between the two attributes, whether first attribute is related to second attribute. So name and register number. So student name and student number, both are definitely correlated with one another. So if I put a name, I will not get the register number. If I put the register number, I will not get your name. So there is a lot of 100% certainty, 100% confidence that one field is related to another field. So that is where a strong association is going to happen. You purchase some items in a supermarket, you say the supermarket bill came for 1000 rupees. So I have to pay the cash of 1000 rupees. So now the relationship was what was to be paid and what is the amount has to be paid. Again, those two items are going to be related. So there we will look with the word called as an association. So whether the rule is correct or not, whether the rule will repeat again and again or not, you need to look. So that is what we call here as the confidence. So confidence, when we are going to take into picture, we take it is A by B. So we take the statistical measures, that probability whether two items are looking at one time and what was the chances to be strong, to be equal. So that is where the confidence is going to be built. And some more interesting factors, what they are going to affect the pattern interestingness will be the utility, the potential usefulness of the pattern, followed by the novelty. So novelty in sense, the idea what we are going to predict should be new in the database, should be fresh in the database, should be accurate or correct in the database. So that is some of the other pattern. Yeah, finally, we were getting the answer at this case or the pattern at this case, and that has to be represented, that has to be communicated. So how is it communicated or how is it represented means, yeah, it is with rules, with the tables, crosstabs, bar charts and pie charts. So this is how a concept hierarchy is going to be represented. So when we are talking about a data warehouse, we are going to call it as a multi-dimensional. That is, it can be represented in x-axis, y-axis and z-axis. So that's the reason why we call it as a multi-dimensional content. And in this multi-dimensional content, we can go with a drill down, drill up, roll up, pivoting, slicing, dicing. So such type of operations we can make. So what is drill down, what is drill up means, I have a month called as January, February, March like that, and I am going to write the sales, number of sales happened. 100 happened, 200 happened, 300 happened. In this way, every month we are going to write and represent. So that is what we call it as a drill down. So we call it as drill down. So let us say if we are going to call it as drill up. When we say it is drill up, we will pool all the total sales for the entire year 2021, and if we are going to write the total sales is this much amount, we are going to call it as drill up. Similarly, the entire table is going to be happen and we pick a subset of a table. We put a pad, we take a portion of a table. If we are going to select the portion of a table, then we are going to say that primitive as slicing, etc. So in this way, we represent the different way of knowledge. So these are all the inputs. So the first way we have started towards representing the entire focus of this chapter. So we have covered all the issues from this chapter, right from mining to functionalities, patterns, task primitives and major issues. So all were covered from this chapter. So we can start with a new chapter in the next class.